Hello, I'm Stefan Greber, I'm project leader for Lxd, and if you've been watching this channel for any amount of time, you've probably heard me mention the Lxd Rest API quite a few times. That's because the Lxd Rest API is really core to what we do. Every single interaction that you have with Lxd is done through the Rest API, even if the only thing you ever use is our CLI or the now upcoming Lxd web interface. It's behind the scenes, everything is using our REST API. And that also means it's very easy for you to script Lxd or create your integration in any other tool that you have that can just talk to a REST API. We already have some videos kind of going over some of the authentication part. The REST API is effectively offered over a few different methods. One would be just the local Unix socket that is always there and that you can always talk to whenever you're on the same machine that's running Lxd. But then if you go over the network, we're using a TLS client certificate by default to perform authentication. Or you can use either Candid or now OpenID Connect as other ways to authenticate against Lxd. The Lxd command line tool also has an easy way for you to directly access the REST API and send your own queries against it, including some amount of knowledge around the kind of answer to expect from the Lxd API. Here in our documentations, you can see a few kind of top-level instructions for how the REST API works. The API is versioned, currently we're at version 1.0. There's no other versions currently available, but if we ever need to break the API, we're going to be going with like a 2.0 at the root, so that there's no confusion or issue there. And in theory, we could support both 1.0 and 2.0 at the same time. The REST API can return a few different things. It can return just a valid, like standard response value, or it can tell you that something is happening now as a background operation, or it can give you an error. When you're dealing with a background operation, you get a operation URL, as well as, sorry, actually here, you get the operation ID, and from that you can actually go to the operation URL to wait for it to be done. Or if you want something more performant, you can actually go and connect to Lxd's WebSocket API, where you get live updates on every single operation in the background, saving you from having to go and poke all of them separately. Error responses are just basic error strings. And to go back on the old background operation thing, the general design of the Lxd API is that anything that we expect to take more than a second or so to run will usually be a background endpoint. So when you hit it, you get a background operation identifier, and then it's your job to go and wait for that to complete. Part of the reason for that is we don't like having a lot of stuck HTTP requests on the server. Even though that's pretty cheap to have in Go, we don't really like it. And so we tend to prefer spawning a background operation and then giving you kind of updates as that happens. That's the other main benefit of those background operations is the Lxd server can provide updated metadata throughout the lifetime of the operation. That's how you get things like the downloading or unpacking progress in the command line. That's because those are metadata update on the background operation. That's part of the creation. There's also a list of status codes you can expect. It's generally lined up with HTTP error codes as far as the ranges are concerned to an extent. But we have some fixed values for standard things on our side. The API also allows for some amount of recursion. Most of our collection endpoints, whether it's like instances, images, storage volumes, that kind of stuff, they support a question mark recursion equals type argument. If you pass that, instead of giving you just the one next level, like the list of URLs, for example, for the next level of objects, it will actually go and recurse and giving you a full list of objects, or even like list of objects if you want to go all the way. That's how we can do things like Lxd list in a single REST API query, is because that one actually uses recursion equals 3, I think, to get all the data for not only all the instances, but also their snapshots and state and all that stuff in one go, saving a lot of back and forth over the API. Some endpoints, again, like images and instances, support server-side filtering. So you can pass a somewhat complex filter directly as a URL argument, allowing for the server to filter things instead of having to do it on the client side. That can be a big time saver, especially when you're dealing with clusters with like thousands of instances. Being able to filter for like a specific machine, a specific config key, or specific status really helps by not having the server have to load that much information for you. As mentioned earlier, the notification side of things is handled through a WebSocket API that gets you notifications on the operations, but also logging and lifecycle events. The API does support both put and patch for updates. Our CLI tools tend to always use put because it's very cheap for them to both get the information and put again. It's worth mentioning that the REST API does support e-tag validation. So if you do get, update, and put, it's a good idea to fetch the e-tag and put it as a condition when you put, so that if anything changed on the server side in between, you get an error instead of like effectively losing data. That's something, again, that our CLI does by default. And yeah, there's a note there that we used to have /1.0 containers and /1.0 virtual machines. Those are effectively deprecated at this point, and you're supposed to use /1.0 instances, which gets you both. And you can use a filter to filter one or the other if you want to. So that's most of what's going on there. The other thing is, if you want the actual API spec, we're using Swagger, like a lot of projects with the Swagger UI. That lets you see all of the endpoints and what kind of methods can be used on any of them, and some examples of the structs that are expected. That works pretty well to get a feel for the general structure of the API. The other thing you can do is just use debug mode on the Lxd command line tool, and then you can see what we sent to what endpoint, making it a lot easier to do your own thing. And with that quick overview, let's go to a terminal and just poke around for a bit. So here I'm in a fresh VM that's currently not running anything. So we're just going to launch a basic Ubuntu 22.04 container and call it U1. And I'm going to pass /debug so we can see what's going on. So now we are getting a status update. So that's an background operation update. Okay, it's launched. But if we look, we can see what's actually happened here. So let's look here. Just need to go up a bit to see. Oh, actually, let's go from the beginning. See what the CLI did. So the CLI connected to the Unix socket. It's then fetched 1.0. 1.0 includes the list of all the API extensions that the server supports. You can use that to know whether a specific Lxd server supports a specific improvement or feature. It also gets some more information around like the server certificate and its configuration. That being done, it then connected to the image server to resolve the image we passed. And with that done, it then actually performed the actual request towards Lxd, which is here. So it posted to 1.0 instances, and the data it posted is this. So we can see that it didn't care about the architecture or any of the extra config because I didn't ask anything special. The name here is set as U1. If it was empty, then the server would set a name instead. And the source for that particular instance is defined here. So we can see that it's using the images container.org image server. The protocol is simple streams, and the requested image is Ubuntu 22.04. It's in pull mode, which is the only thing that makes sense for the public image servers. If you are downloading between two Lxd servers, it could be push instead here. And we don't allow any kind of inconsistency, but that part is only required for if you are doing migration instead of creating from an image. Instance type is not set, so that would be your Amazon or GCE or whatever type instance types, like an M1 micro or something like that, if you wanted to set the size in one shot. This is not specified. We can see the type of the instance, not to be confused with instance type. Sorry, we didn't really foresee us adding virtual machine at the time we added instance type, so it got a bit confusing. Anyway, the type is container, and then Lxd said, okay, cool, that's created. So there is a background operation going on for you. That's the ID. And we can see the description is creating an instance. It also gives us some pointers so we can see what the URL is going to be for the instance once it's done. Lxd then actually fetched the operation. So we can see it here. It then waited for the operation to be complete. So that's done through the event handler in this case, so you don't see it in the log. But it was waiting for the operation to say that it was complete, which you could tell by status going to what is it, completed or something like that, so 200. And once that was done, it fetched the instance again to just make sure everything was good. And then it put to the state a request saying action is to start it. The instance then, Lxd then created a starting instance background operation, which the CLI again waited for and then retrieved to make sure everything was fine. At which point we've got an instance. So that's basically what's involved with creating an instance. You could do it much simpler. The CLI, because it uses kind of Go client library to an extent, will do more than is strictly needed. You could totally just put to 1.0 instances what you want, wait for that to complete and be done. In this case, we did go a bit extra by downloading some extra data and by editing it. The one thing that's worth mentioning is that there is no launch endpoint. It's a two-step operation to both create the instance and then start it. So that's what we were seeing here. Now, one easy way to poke around the API is to use the Lxd query command. This is not a visible command, so you won't see it in the help unless you pass --all. But it lets you send raw queries to Lxd, and not only your local Lxd, but also a remote Lxd that you've got defined as part of your remote list. So you could do just query / just do 1.0, you can go 1.0, just use that endpoint. If you want to go to look at the instances, you would see the list of instances. Now that's where recursion comes into play. So if I do recursion equals 1, it shows me the instance. If I do recursion equals 2, it will go one level more and actually show me also the current runtime state of the instance. It will also show me its snapshots and some other details here. And I think recursion equals 2 gets us what we want, but if not, like if some details about the snapshots are missing, then you could go one more level and actually get absolutely everything. So that's kind of how the recursion stuff works. Now this is done through the Lxd CLI, but you could do the same thing with curl if it's installed. It's not. Okay. Curl has a very convenient option called Unix socket, so you can point that to the Lxd Unix socket, and then whatever you want, the first parameter here doesn't matter, but then we do 1.0 and you get that. The other thing that's worth mentioning, I guess, at this point is that if you compare this to the equivalent here, you'll see it's a bit different. The Lxd CLI knows about the general structure and will effectively get you the actual content, so the metadata here, instead of showing you the full answer. It will also do formatting for you, whereas the API does not. There's some extra thing you can do. So you can do --raw, which will still get you the formatting, but will not hide the full response effectively. The other cool thing you can do is you can do --wait, which doesn't make sense in that case, but wait, if you get a asynchronous response, so a background operation, it will wait for it to complete. We could try that by actually doing, say, raw and post to 1.0 instances and see if by some kind of miracle I can remember all the stuff I need to pass. So the name is the main thing we want here, and then we want the source, and the source is also a dict. I think it's type. We need to set it to image. Protocol is gonna be simple streams. Now whether it's server or URL, I'm not actually sure anymore. I think it might be URL. Not sure. Let's see. Okay, and I know it's Alliance that we want to be Ubuntu/2204. Why don't we try that and see what happens? cannot marshal string into value instances post. Okay, so I messed something up as far as the short typing of this stuff is concerned. So let's go over that. Name U2 is good. Source is a dict, which is type image. That seems fine. Protocol, that seems fine. URL, that seems fine. Alias seems fine. That closes that and that closes the other one. Okay, there's nothing obvious, which is to say there's something very obvious that I'm not seeing. Anyway, let's go look at the actual request from earlier, if I still had that, which I don't. Let's see what I might have done wrong here. Get a string into value. Okay, so it sees it as a string overall instead of it being passed. I wonder if the raw actually is causing issues here. Nope, that's not it. So we're posting to this thing. Okay, well, let's narrow it down a bit. So if I just do this, and that wouldn't really be valid, but yeah, there we go, unknown source type, cool. So, oh, yeah, I see it. I forgot to put quotes here. I'm sure some people were literally yelling at the screen. I'm sorry about that. Okay, image alias not found. So that means URL is probably wrong. Let's try server. Yeah, that's better. Okay, so in this case, it did wait. So it showed me the creating an instance request and it shows me success. And it shows that it was created U2. And here we go. As mentioned, it will not start it. So that's normal. If we wanted that to happen, we would need to then go U2 state and post and action start, post that to, okay, what did I do wrong this time? Instances U2 state, oh, is the put on that? I think it's put. Yeah, there we go. Okay. Just using the wrong verb. And it's running. And if you wanted to look at what's the state data looking like, there we go. So that was using Lxd query. If you wanted to do the same, so if I take that request, I think that's the one that worked, and convert that into a simple request with curl, it would look, I think it's still X and D. I think we stole that syntax from curl. So let me do U3 instead. No, you're specified. Yeah, right. Lxd 1.0 instances. Okay, so we can see here we got the operation created. Now we would normally need to go and immediately query that path with /wait or something to wait for it, but we'll have it already expired. So we can see it got created here. And then if we wanted to do the same as earlier, we can do instances U3 state. And here, just go there, do action there. So start, and it's a put. Okay, and now it's running. So that's kind of the basics there. Now, let me see if I've got a certificate generated on the client side. I'm not sure that I do at this point. Yeah, I don't. Okay. Just need to connect to some random server. I think that will actually just generate it. Yeah. Okay, so now if we generate a client certificate and say we've got that certificate trusted by Lxd, config client certificate. Okay. So now our Lxd trusts that client certificate, which means that instead of accessing it over the Unix socket, we could access it over the network. First thing is to make sure Lxd actually listens over the network, which is done now. And we don't know how to validate the certificate, so let's just not. And then find the IP address here. So if we go 10.1.4, the other one, 172.17.250.83 on 8443 1.0. So and let me install JQ so we can actually read that. Okay, so now we can read it, and we can see here that auth is currently untrusted. So we effectively have no real access to that Lxd server. We can't go and look at, say, instances. That's gonna fail, not authorized. But it's the access that you need to access things like public images on Lxd. Now, if we want it to be authorized, what we would do is now pass the client certificate to curl, which I don't actually remember how to do. And I don't suspect I've got man installed. So let's see if that -help helps us. And it doesn't. Okay. Help all apparently is a thing. Okay. So cert type. Okay. So -e would be certificate. What's the key? Okay. --cert -key. Cool. So let's do --cert and then snap Lxd command config client cert. And key snap Lxd command config client dot command key. There you go. Okay, and if we query that, now we're getting more stuff. And more importantly, if we can find where it is, it should tell us we're trusted somewhere on there. Yeah, there we go. Auth is trusted. So now if we access, if we go ahead here and we access /instances instead, now we can see them. So that's what you would want to do to access Lxd over the network with just certificate authentication. If you need to go the Candid or OpenID Connect route, it's going to be quite a bit more complicated. So you're going to need to use probably some kind of third-party code or library to handle that for you. But for client certificates, that's all you need and works pretty well. The one thing I can't easily show is the events API, because that's WebSocket and curl doesn't really do it. There are third-party tools that do the same thing as curl but do WebSocket properly. So you could use that to access /events instead. If you hit /operations, you will actually see any kind of background operation that's running. And you could do recursion = 1 to get their details. In this case, I don't have anything, but if I was to disconnect from there and go in here, and now I was to get the shell instead of U1, yeah, and I look at the operations. Now I've got an operation running that shows that I'm executing a command, and it's the bash command being run inside of instance U1. So that lets you see what's going on as well. And I've been doing all the demos and stuff with instances, but again, everything we do in Lxd uses the REST API. So if you want to go look at networks, you can. Same thing for storage pools, same thing for everything. And that involves literally everything. So if you need, you might have seen both our CLI and WebUI let you access the VGA console of virtual machines. That's also done through the REST API. It's not the easiest thing to handle, but effectively you can, I believe it's a post or a get to, there's an endpoint for instances. We can actually poke at here. So if I do instances U1 console and I get that, it's not, there we go. This one doesn't have a console anymore because we just read it. So if I do it on, say, View2, there we go. We get a text console out. So that's the endpoint for the text console. You can also access a different console, which is the VGA console. That only works on VMs. And if you do, what you get is a background operation that gets you an API URL that you can then connect through with WebSocket. And that will get you access to the Spice API. If you're in the CLI, you need to do something kind of like what we did in the official Lxd CLI, where we connect over WebSocket, then we forward that to a local socket, and then we pass that to a normal Spice client like VodViewer or Spicy. If you're in the web case, so like the Lxd UI, what we did there is we used as an HTML5 Spice client, which was already using WebSocket to access the Spice stream. And we noticed it is just perfectly compatible with our server-side implementation in Lxd. So we just pass it the URL you get from the creation of the console operation, and it just works. All of that kind of stuff, really the easiest, as I mentioned earlier, is to just use --debug on the CLI. It will show you exactly what happens. That tends to be a fair bit easier than going through the examples in the documentation here. Part of that is anything that uses WebSocket can't really be represented all that well inside of Swagger Open API type models. So yeah, it's not always like things like, the SFTP API we have here. That would be an example of something we can't really cover. And it just says upgrades to an SFTP connection to the instances file system, and that it switches protocols to SFTP. But it can't go in details about what the SFTP protocol is. For that, you can need to do it yourself, or you need to look at what we've done in the client. But for more simpler things, like whether it's like instance creation or that kind of stuff, or in this case listing instances, there you've got all the examples of the different response you can get, and you can also go look at the models for what's expected as far as data. So you can go and expand all of the structs. It's not necessarily the easiest thing to go through, but it does line up with examples for every single thing. You can also download the Swagger model directly and then open that in a tool with more horizontal space for you to look at things. And some of the endpoints, like the metrics endpoint, those are just giving you raw data. So maybe I can just show that briefly before wrapping this thing up. If I was to go to let's do actually let's do curl, that's fine. So if I was to do /metrics here, you just get raw open metrics information. So there's no JSON or anything, it's just straight up open metrics. That's so you can use it from Prometheus. The same is true if you want to access a file instead of an instance. So there's a complex SFTP API that's super efficient and that we're using these days, but we also have a much simpler API for files, which is something like this. So if you want to look at Etsy hosts or I don't know, varlog syslog, you can just get varlog syslog and it will literally just give you the file. Same thing if you want, say it's Etsy hosts. And the thing that's interesting is that it even works on stopped instances. So if the instance is not running, you can still access it. And Lxd will do whatever is needed. So if you're in a cluster, it will forward that to the right machine. If the instance is stopped, it will mount the file system of that instance to just get that data out for you. That's all very nicely integrated. You don't need to think on the client side about, oh, this instance is stopped, I need to turn it on, what server is it running on, or that kind of stuff. Lxd will just do the right thing. The other thing that's kind of interesting if you're operating a cluster is some responses are kind of machine specific. 1.0 networks could be one of those, for example, where it will show you local devices as well. If you were in a cluster, what you could then do is say you've got a server called foo, you could do target equals foo. And Lxd will then forward that request from whatever machine you just hit with the request over to the machine foo internally. You don't need to know about all of the IPs and all that stuff on your side to send the right request. Within a cluster, you can just tell Lxd where you want to go and it will route you there. And I think that's it for a reasonably short overview of the Lxd Rest API and kind of the rough ideas of how it works and how to interact with it. Lxd Query is really a great tool to get started because it abstracts a lot of some of the weirdness and stuff that we have. It also does effectively authentication for you. Like if you use Lxd Query on a server using OpenID Connect, it will just do it for you. It will do the same thing with Candid and RBAC. You just send queries and it takes care of the authentication, all that stuff. And it can also, as we saw, extract the data from some of the underlying structs. And it can also handle operations, wait, and those kind of things. Anyway, I hope this was very useful for you. There is already quite a lot of tools interacting with the Lxd API out there. Chances are you've probably used a few of those already. But if you want to, whether it's doing your own script or it's just writing some new third-party tool to interact with Lxd, hopefully it was very useful to understand how this all works. Anyway, if you got any questions about this, feel free to leave them down below or go on the community forum and ask us questions. And I'll see you in the next video. Bye.